So now in this class, we will get started with Green's theorem. So Green's theorem is very, very important. Let's see the statement and the proof. So first, let's give the statement. So Green's theorem states that for a closed region, S in xy plane bounded by a simple closed curve C, if M and N represent two continuous functions of x and y, then curve integral m dx plus n dy equals to surface integral dou n by dou x minus dou m by dou y into dx dy. So this is the statement. So now let's get started with the proof. So look at the figure. Consider any line. First you need to draw the figure. Consider any line parallel to the coordinate axis cut the curve C at 2 points as shown in the figure. Now we assume C to be a curve bounded between the lines x is equal to A, x is equal to B, and then y is equal to C, y is equal to D. Now let y is equal to f of x be curve C1, that is AEB, and y is equal to g of x be curve C2, that is the curve BFA if you look at the figure. Now you consider surface integral dou m by dou y dx dy is equal to outer integral limits are x is equal to a to b, inner integral limits are y is equal to f of x to g of x. Dou m by dou y dy dx, that is equal to integral a to b. Now what is integral dou m by dou y? It is m of x comma y. After integrating, we have to apply the limits. Lower limit is f of x and upper limit is g of x dx. Now that is equal to integral a to b m of x comma g. That is, we have to apply the upper limit first minus m of x comma f, that is the lower limit dx. So which is equal to integral a to b m of x comma y dx minus integral a to b m of x comma y dx. Now here we interchange the upper limit and lower limit. So we need to take a minus outside whenever we interchange the limits. So that is b to a m of x comma y dx minus integral a to b m of x comma y dx. So this is nothing but minus curve integral C2 m of x comma y dx minus integral C1 m of x comma y dx. So therefore, surface integral dou m by dou y dx dy is equal to minus of curve integral m dx. So curve integral is a single integral, surface integral is double integral, volume integral is triple integral. Now let x is equal to f of y be curve C1 and x is equal to g of y be curve C2. Then double integral dou n by dou x dx dy is equal to, now we apply the limits. Here y is equal to c to d and here x is equal to f of y to g of y. Dou n by dou x dx dy. Now here outer limit we write as it is, outer integral. Now inner integral we will solve. So integral dou n by dou x dx is n of x comma y from limits f of y to g of y. Then again we write dy as it is. So that is equal to integral c to d. Now we apply upper limit minus lower limit. So n of, in the place of x we put g of y. So g comma y minus n of f comma y dy. Now that is equal to integral c to d n of x comma y dy minus integral c to d n of x comma y dy. So that is integral c to d n of x comma y dy. Now if we interchange the limits, we can take a minus. So minus into minus will become plus d to c n of x comma y dy. Now how can we write? That is equal to curve integral n of x comma y dy plus, this is second curve, that is C2 n of x comma y dy. So curve 1 plus curve 2 will give you one single curve, that is n dy. Therefore, surface integral dou n by dou x dx dy is equal to curve integral n dy. This is equation number 2. Now we add equation number 1 and equation number 2. So we get curve integral m dx plus n dy is equal to surface integral dou n by dou x minus dou m by dou y into dx dy. Hence proved. Now we will continue with the vector form of Green's theorem. So what is the vector notation? So the vector notation of Green's theorem is given by curve integral f bar dot dr bar is equal to region integral del cross f k cap dx dy, where f bar is equal to ni bar plus mj bar, r bar is equal to xi bar plus yj bar, and k cap is the unit vector along the direction. And what is the application of Green's theorem? Electric field due to long infinite wire. So this is used in electric field due to long infinite wire.